All right, I have two examples up here we're going to work through. When I work through these examples, basically on these two, I'm giving one trig expression and I want to simplify it. These are just a basic simplify. Basically, you're trying to discover your own trig identities here. When you're trying to simplify these expressions, it's important to write out the reasoning that you used in each step. So some sort of algebra technique or some sort of fundamental identity, okay, to move forward to the next step. I'm going to call these two-column proofs, I guess, for lack of a better term. And so basically you're going to write out a step of simplification, and next to it you're going to write out the reasoning that you used for each step. And so you'll have two columns going, one for the simplifying and one for the reasoning for each step, okay? So in this first one, a very common technique is to turn all of the expressions into sines and cosines. It doesn't have to be your first step, but here I've already got sines and cosines involved, but then there's a cosecant. And cosecant we know is 1 over the sine, and so that could help us as we move forward, just to get everything in terms of sine and cosine. So I'm going to go ahead and do that. We'll start with sine squared x over the cosine squared x plus the sine of x. Now the cosecant is actually 1 over the sine, like I said. So I multiply by 1 over the sine of x. Now the reasoning that we used in that step is a reciprocal identity. So I'm going to write that down, just reciprocal identity. Okay, a reciprocal identity. My next step here, I notice that my sines, I have a sine on top and a sine on the bottom, right? Sine times 1 over sine, they cancel and give 1, right? So these sines cancel out, so I have sine squared x over cosine squared x plus, well, that'll just be a 1. And that's just reducing common factors, right? Then when we get into some of the algebra things, like reducing common factors, you could say canceling, multiplying by a reciprocal. There's a lot of different ways that you could explain what you're doing, as long as it's valid, right? As long as it's true. So I would just say something like cancel common factors. But again, you could word that slightly differently and get the same, content, I guess. Okay, get the same point across. At this point, I notice that the sine squared over the cosine squared, well, I know the sine over the cosine is the tangent, right? That's a quotient identity. And so the sine squared over the cosine squared must be the tangent squared. So this would be equivalent to the tangent squared of x plus 1 using a quotient identity. Okay, so quotient identity gives us that. Now there is also a Pythagorean identity that equates the tangent squared plus 1 to the secant squared. All right, so tangent squared plus 1 is equivalent to the secant squared of x, and that's by the Pythagorean or a Pythagorean identity. So it's going to be important for you to not only know how the identity applies to the expression, but also what the name of it is, okay, so that you can accurately represent your rationale for the step. Now my math lab kind of breaks these down for you. It will give you an expression like this, and then it will give you a step. It might have something like this next step here, but instead of having, I'll get rid of this where I cross these out. Instead of having the sine of x on the bottom, it might have a blank here. And then it may say fill in the blank and apply the appropriate fundamental identity. And so you would have a drop box over here with a list of identities. You might say Pythagorean identity, reciprocal identity, quotient identity. And you pick reciprocal identity because that's what you're using, and then you have to fill in the box with what is needed to make that take place. So you would fill in the box with sine of x, okay? So my math lab will have some of those, that's how, I don't know how to say this, that's how these are going to be structured. So it doesn't give you a real nice way to write out your proof like this, even though I really want you to practice this idea. So it might be a good idea when you're given a problem on my math lab, not to just start by filling in the stuff, but maybe start by just simplifying it like I did. Just run through the whole thing and then go through my math lab and just pick out what needs to be inserted, okay? I think that'll be helpful. When it comes to taking a test, you're gonna need to fill in all of this. I'm not gonna have you fill in like little boxes and have it outlined for you. You're gonna have to come up with the whole thing. So if I give you an expression, you're gonna have to simplify it and give me the reasoning for each step, okay? So, my math lab, that's one of the downfalls to an online homework system here, is that you're kind of put in a box, for lack of a better term. I don't know, bad pun. But it kind of restricts what you can, how you can approach these problems. But it's still good practice, and it's still going to be necessary for you. I think you'll still learn from it. So, but just know that when it comes to testing time, you're going to be expected to be able to fill in this material. Moving on to the second one over here. Let me get rid of this one. Again, I think it's useful as I look at this one to simplify. I would turn this secant, the 1 over secant, into an expression with sines and cosines if possible. Here, I know the 1 over the secant is equal to the cosine, right? Cosine is a reciprocal of the secant and so forth. So 1 over the secant squared must be equivalent to the cosine squared. So I have 1 minus the cosine squared of x, and that's using a reciprocal identity. Okay. Then there's a Pythagorean identity. Now this one's not as clear. You know that, hopefully, that the Pythagorean identity, the one I wrote up here in the previous video, sine squared plus cosine squared is equal to 1, right? Well, if you were to look at this identity here, and if you were to subtract the cosine squared from both sides, think about that. You get sine squared x equals 1 minus the cosine squared x. Well, this 1 minus cosine happens to be our previous step in that in this problem here. So you can replace 1 minus the cosine squared with the sine squared, okay? So this is equal to, and I'll separate this off, equal to the sine squared. And that's using a Pythagorean identity or a variation of the Pythagorean identity. Now, you could just write in here Pythagorean identity. But of course, it's not the Pythagorean identity in the form that you're familiar with. It's an alternate form, but that's okay. I'll accept Pythagorean identity because that's really what you used. Any of these identities can be written in alternative forms, like particularly the Pythagorean identities. You could move things around the equal sign and just get slight variations that are equivalent. So you can just use Pythagorean identity here. This is as simple as it gets, right? Sine squared, you can't really get any simpler than that, so that would be your final simplified form.